Everyone, I am Suhas. I am here to explain my project in Emertxe about automated washing machine using PICSIMLAB. I am basically from Kalpataru Institute of Technology, Tiptur. Here's the contents of the project where we will learn about introduction to the C programming, about knowledge about controllers and microprocessors, embedded system and need of microcontrollers, and the two usage of my PICSIMLAB. Here's the introduction about the washing machine. All we know about washing machine is like it's a machine where we are it's used to make our lives very easier, and in modern world washing machine is a necessary tool which is used to wash the clothes and dry the clothes. There are many washing machine brands where we are using in this modern world. Mainly the washing machine are composed of hardware and software. It's an embedded system where we can find the hardware and software components and working a particular job which we are preferred to it. A washing machine has a controller, sensors, actuators, microcontrollers to perform them but a specific task. Now let's talk about the C programming. In this program we are using the C programming language in order to code the washing machine and to work the washing machine. Now let's come for a basic concepts of C programming used in this project. Number systems. Let's talk about some basic concepts in C programming. Number systems, data representations, data types, operators, arrays, functions, strings, classes and pointers. Number system. There are many number systems which are present like hexadecimal, octal, so on. Data representation means we are representing some data in a form of bytes and words. Data types, where we declare the data if a type of int, char, float, boolean or double. Int means the integer types, char means the character types where we can declare the names, etc. Float means where we can declare the decimal types data. And let's go for the further operators. There are many operators like arithmetic operators, logical operators and the boolean operators. Arrays are the collection of same data types. Array is the collection of similar type of data items. Function is a basic building block of the C programming where it contains the statements and instruction sets within a curly brackets. The string is the collection of the array of characters. Pointers are the variables that holds the address of the different variables of the same data types. Now let's move on to the difference between the microcontroller and the microprocessor. Microprocessor has the CPU stand alone and the other parts like RAM, ROM and input devices and the output devices, they are separate, which we have to connect them externally to the CPU. But in case of the microcontroller, the CPU, RAM, ROM and input devices are connected in a single chip which are integrated together, where in the microprocessor the designer can decide how many amount of RAM, ROM or the input ports we have to provide. The manufacturer can decide that. But in the microcontroller there will be a fixed amount of a RAM or the RAM capacity or the ROM capacity or the input port capacities. Microprocessor costs more expensive than the microcontroller because of the separate parts of the RAM, ROM and the input ports like that. Microprocessor is more expensive compared to the microcontroller because of the separated parts of the microprocessors like RAM, ROM and so on. But in the microcontroller all will be integrated in a single chip, so there will be a less expense for the user. Microprocessors are used for the general purpose applications, whereas the microcontrollers are used for the single purpose applications. Like there will be a program for using for a single purpose, and they can't use for the multiple purposes. Microprocessors are versatile and the microcontrollers are not versatiles. Let's now see the need of microcontrollers. Microcontrollers are essential components in a wide range of electronic devices and systems due to their ability to provide computational control in a compact and efficient manner, where they are very efficient in the work-wise manner. They are used in embedded systems, real-time control, low power consumptions, cost effectiveness, and integration. Now let's talk about the embedded systems. Embedded systems are basically defined like this. Embedded systems are the combination of hardware and software components used for the specific task or designed for the specific task. Unlike general purpose computers, we can't use these embedded systems or the microcontrollers in the general purpose manner. Likewise, in general purpose computers, we can't use the various applications or we can't do multitasking in the embedded system or a microcontroller. These embedded systems are dedicated to perform a specific task. For example, consider a washing machine where it should notify the user after the washing the clothes that it's done or the washing has been done, and or it should be switched off automatically. This process is done through the embedded systems. It's called as the purpose built functionality. Or for example, an anti-lock braking system in a car needs to react instantly to prevent wheel lockup during the braking. This process is the real-time operation where we can see the embedded system working in real-time operations. There will be a time consistency. It should respond in a given time or in small instant of time. And the third thing which we have to see is the resource constraints. The embedded system has the limited resources which we have to design or to build that embedded system. A designer must optimize the use of these resources like the processing power, memory, and the energy. Give the efficient operation and meet the performance requirements. Types of embedded system. There are two basic types which we can be classified according to the requirements and according to the performance of the microcontroller. In the functional requirements, we will come across the real-time, standalone, networked, and mobile. And whereas in the performance type, we can see the small scale, medium scale, and the large scale or the sophisticated scale. Next, we will see the block diagram of the embedded systems, where we can see the sensors, which are the input devices, and they're the actuator and the inductor, which are the output devices. The main part of the embedded system is the processor, which processes the input and gives the respected output according to the needs and the inputs. Next, the fundamental aspects of the selecting microcontroller. There are many parameters which we have to look over to the buying of a microcontroller or the purchasing of the microcontroller. Some are the power efficiency, temperature tolerance, hardware architecture, processing power, memory, hardware interface, software architecture, and the cost. These are the main things which we have to look over a processor or a microcontroller buying while we choose for a project or something which we want to do. Now let's go for the problem statement which we have been provided for the project. This project focus on the simulating a washing machine using PICSIMLAB, aiming to replicate real-world washing machine functionality in a virtual environment. The project begins with a comprehensive understanding of washing machine components, cycles, and operations. Parameters defining laundry status such as fabric types, loading size, and water level are identified. where we have to design a washing machine using the PICSIMLAB. In this project, we are going to code the necessary coding in order to perform the specific tasks which have been provided by the problem statement. We are going to use these tools for the project creation. The MPLAB IDE, which is used for the coding of the C language, where we can code in the C language and we should convert it in the EXA file. XC8 compiler is a compiler provided by the microchips company in order to compile the code written. PICSIMLAB is a software which is used to simulate the code which has been written in the MPLAB in the virtual manner in the virtual boards in the PICSIMLAB, where we can provide the necessary inputs and we can get the necessary outputs by providing the program which has been written. There are many components which are we using for the washing machine program. There are many components like LED. LED is a light emitting diode, which is a semiconductor device which emits the light when the electric signals passes through it. In the PICSIMLAB, the PICGenius board, the LEDs are connected to the port B and port D. In the coding, we had represent the trace B for the input of the LED, where the 0 represents the output and 1 represents the input. The tactile switches. The tactile switches allows electricity to flow in an electric circuit by manually pressing the operation section. The switches activates when pressed and then turns off when released. Next is the interrupts. Interrupts is a signal emitted by a hardware or a software when a process or an event needs immediate action. Timers. They are used to keep a record of time for different events occurring in the embedded systems. There are 3 types of timers in the PICSIMLAB: timer 0, timer 1 and timer 3. It maintains the timings of an operation in sync with a system clock or an external clock. CLCD, Character Liquid Crystal Display. A liquid crystal display is a mode of display used in digital equipment, replacing many other modes of display such as cathode ray tube, LED displays and plasma displays. In PICSIMLAB, we have 2 types of display: 16x2 display and 16x4 display, where we have 2 rows and 16 columns in the 16x2 display and 4 rows and 16 columns in the 16x4 display. Digital keypads. Digital keypads are widely used as input devices, being used in various electronics and embedded applications. They are used to take inputs in the form of numbers and feed the same into the systems or to further processing. Now let's talk about the PIC16F877A, a PICGenius board from Microchip. It's a high performance RISC computer, CMOS technology, built in timer 0, timer 1, timer 2. It consists of 5 ports: port A, port B, port C, and port T and port E. There are many bits of organized ports, like port A is organized with 6 bits, port B is organized with 8, port C is organized with 8, port D 8 and port E 3 bits. They are used for different application purposes. Now this diagram represents the port organization of PIC16F877A, where the ports are being organized from 1 to 140 pins. Next, the functional requirements. We can see the image which represents the functional requirements of the project. The switch 5 should work as the power on switch. The switch 6 must pause or stop the program. The switch 4 should act as the navigation key in between the mode selection etc. The switch 1 should act as the door status, which way represents the on and open or the close of the door. The display microcontroller display of the washing machine is being displayed in the CLCD. Buzzer is used to notify the on status or the off. When the door is opened, the buzzer will on. The motor is used to represent the spinning or the washing of the clothes in the washing machine. And the microcontroller which we are using in this washing machine program is PIC16F877A. Let's see the event procedures. As soon as we power on the device, we want to simulate to show a message like powering on the washing machine. After powering on, the simulation should show all the washing modes. Simulator also contains matrix keypad, and with the help of its key, user will able to choose the respective modes. In this particular design, we included pause button that will pause the time count and will turn off the device until it is released. After completing the event, time up message will be displayed on the CLCD. This is the requirements which has been given to us. Next, the modes of the operation. We will see the different modes of the operation like washing programs. The washing programs contains many types of washing types like daily, heavy, delicates, whites, echo, cottons, rinse, dry, washing only, drying only, stain wash. There are many water levels which we have to set for the water levels also. Water levels can be auto, low, medium or high based upon the requirements we have to give for the user. Now this screen shows the PIC16F877A microcontroller board which has been used as an embedded system. It's an virtual board where we can use as the washing machine we are using as the currently using as the washing machine program. This board is now using as the washing machine program where we will simulate the program and see the necessary output in it. Now let's go for the programming part. Now we are going for the MPLAB IDE where we had been declared the washing machine program file, and we have been written some codes in the header files and the source files where we are representing some many files which have been created by us. In the MPLAB IDE we have been written the program already, and I am trying to run this program now. Here we can see the header files, and here are the source files which we had been declared. Now let's clean and build this washing machine program. It has been clean and built. Now let's see if there is any error in this program. No, it's showing that there is no error. The exa file has been created and also showing the build successful. Now let's go for the PICSIMLAB. In there the files, load exa, in that load exa, and we'll select the default where had been stored the program, washing machine program, and let's load it. The program has been loaded. See there it's showing that press key 5 to power on washing machine. Let's press the key 5. This is 0, this is 1, this is 2, this is 3, this is 4, and this is the fifth key which has been declared as RB4. It's the fifth key. Press the switch RB4, which is the switch 5. It's showing the powering on the washing machine. Now it's showing the washing programs, daily, heavy, delicates. Let's use the switch 4 to navigate between these. There are showing many woolens, bed sheets, many washing programs. Switch 4 is used to navigate between these washing programs. Let's long press the switch 4. Let's select this daily washing program. Yes, selected. Then the water level, medium, high, auto, maximum. Now let's select the auto mode by long pressing the switch 4. Now it's showing that press switch 5 for start, switch 6 for stop. Now let's press the switch 5, program daily, timer 0. It's showing that the program is running. Yeah, we can see that the washing program has been started for running. The fan is been running over there, and let's try to stop by pressing the switch 6. Yeah, it has been stopped. Let's start again by pressing the switch 5. Again the fan is running. For seeing that the door is open or closed of the washing machine, let's try the switch 1. If the switch 1 is pressed, it's showing that door open, please close. And when we switch 1 is pressed again, then the washing machine is running again. This washing machine will run till this timer ends, and the clothes will be washed again till the timer runs. Yeah, the timer is been stopped. It's showing that the program is complete. Please remove your clothes. It's been showing the program completed. Please remove the clothes. We can hear the buzzer sound when the door is opened, and we can hear the buzzer sound as well when the program is completed. Yeah, this was the project to demonstrate the washing machine running in a virtual manner in the PICSIMLAB. Thanks Emertxe for providing us the opportunity to learn about the embedded systems and demonstrating the project hand-on, which was the washing machine project. Like, we had learned many things from it, and it was very useful for us. Thank you Emertxe. Thank you for giving the opportunity to explore the new things and come up with some new ideas about the embedded systems and using the PICSIMLAB. Thank you Emertxe. Thank you.